So, as you guessed, we are going to be talking about the forest fires today and what can we do about them. So, I'm from Turkey and we had enormous wildfires back in 21 and I tried my best to help people out. I was a volunteer drone pilot and seeing everything from the inside, we come together as a team and said, we can do some things better. So, we focused on the early detection. And just to give you a general idea, only last year, in 2022, 900,000 hectares were burned. To put that in perspective, this is where we are in Amsterdam. And when we put the area that burned, it gives you a diameter of 30 kilometers. So, it's a lot. And as many of you know what happened in Canada at the start of this year, there was enormous wildfires for a place known for its cold and climate. And it was so badly burned, it not only affected Canada, but New York as well. And flights were canceled, and the air quality was so bad, they have to invent a new level of air quality index. And this was taken up from New York, and this was the air quality. To put that into perspective again, we have a live device at EchoStar mobile booth at the moment, and it's seeing 57 at the moment, and this was around 400. So, let's cut to the chase. So, why wildfires get out of hand? Because we do not detect it at the optimal time amount. So, time spent on detection is too long. When we detect the fire, it has already begun and spread and it's out of control. You need extra infrastructure or very expensive equipment in order to detect them on time, and also high costs. So, in comparison, when you use IoT devices, you can get around like 1 hectare or 2 hectares burnt and you get a notification. And it goes on, and when it gets bigger, you cannot extinguish it very easily. You have to use a lot of manpower, a lot of equipment, and a lot of water. And our solution is simple. We put sensors on the trunks of the tree. And you can imagine this as a smartwatch for trees. And it's, of course, not for every tree. We put one device per 16 hectares. So what we do see, so we measure temperature, humidity, air pressure, carbon dioxide levels, as well as gas classification. If temperature rises suddenly or humidity drops, these are cases of warnings for us. And with the gas classification, we can predict if it is someone is smoking a cigarette, or it is an exhaust of a vehicle, or is it a wildfire. So we started developing with LoRa. It was the perfect fit for us because of the kilometers away, you can send messages, and we had a device sent, like one of our deployments, we had 16 kilometers between the gateway and the device. So everything went well in many of our developments, but when something goes bad, it goes bad very fast. Only problem we had was with the gateways, because when something goes wrong, you have to have some contingencies, you have to have a maintenance crew on hand, and you have to keep the uptime very well. So, but we faced something we haven't foreseen. We had a very bad start as Turkey. We had a devastating earthquake back in February, and when the Hatay earthquake hit, cities were leveled. And in the meantime, many of our deployments went offline, even the ones that were 100 kilometers away from the affected sites, because GSM was down. The GSM network was down and stayed that as a week, and this was unacceptable for us, because when we removed the internet sites from the gateways, the field officers were not notified or not get the sensor data. So this was a sign for us to become disaster-proof. Luckily, thanks to the Things conference, we had been in contact with the EchoStar Mobile, and we swiftly onboarded the LEAP program and developed our first node-to-satellite internet connection. We do have a live demo at their booth. You can examine it. It's currently working and sending data every 2 seconds, every 2 minutes. And even if we are indoor and they are placed it upside down, it still somehow manages to send the sensor data. I'm amazed. They're amazed. Incredible. And so now we integrate the satellite modules. We communicate through S-band. So when our devices detect something is abnormal, it sends the data to the satellite, a geostationary satellite in the orbit, and it sends the data back to a ground station. Then it sends to the servers. Then when in the servers, it passes through an algorithm in order to minimize the false positives and false negatives. And then the authorities are alerted, and they go and fight with the fire. And all of this happens in 15 seconds. When you get the signal, authorities alerted in the 15 seconds. So this is our dashboard. As I mentioned before, we measure temperature, humidity, CO2 levels, VOCs, and air quality, and some magic behind that as well. And with combined data from those with the algorithms, we do have some services that we provide. During a fire, with the live data from the sensors, we can predict which way the fire will go. So this gives a heads up, and it optimizes the way we fight with the fire. And in the event of a fire, we tend to give authorities as fast as we can, and we do have a 30-minute window at the moment, and in some cases, we stopped 8 fires this season, and 4 of them was alerted. We get the alert in first 15 minutes, and just the size of a table was burned, and they were able to extinguish it in the middle of the night. So we can detect it fast, we can alert the authorities fast. And now there comes the hot part, before fire, because there are some indications with the emissions from the field and also the humidity and the temperature. We can predict the probability of a fire in a given area, so we can alert authorities for a preemptive strike. So, what is next for us? We will have over-the-air updates for these devices probably at the end of this year. At the moment, we are protecting over 1.5 million square meters, and we are planning to triple that by the next year. And we are going to be opening a Europe branch in France by the beginning of the next year as well. Yeah, so we are open to collaborations. Our data is open to anyone who wants to play around. And if you're a data scientist, investor, nature lover, reach us. And we are on the same ship. We are on the same ship, which is sinking rapidly. Let's help us save the forests. I'm Batuhan. Thank you for listening. I guess we have about 5 minutes, so if you guys have any questions, I will be happy to answer that.
Hello, thank you for your presentation. One question, what were your considerations to use a satellite connection rather than deploying your own gateways?
So we wanted to be able to go out there as fast as we can. Also, with the gateways deployment process a bit man-hungry, manpower-hungry. So with the satellite connectivity, either we develop in Turkey or in Europe or in North America. We just send the device, and I just flip on a switch, and it's activated, and it's working just in that second. So that is an enormous help on our side as the operations go. And when something goes wrong, like if a gateway goes down, even if you have contingencies, everything connected to that gateway dies. So in order to overcome that, we wanted to every device on its own have their own connectivity. So if one device gets damaged, broken, stolen, the other network will continue to thrive on.
Thank you. Thank you for the presentation. I just want to ask about, like, have you thought of how can this be also used for prevention or mitigating wildfires rather than just curing or making sure that once the fire is there, preventing that? Are there ways that you could use your setup for preventing the fires?
Sorry,
itself?
can I get that last part again?
So right now, like, I understand, like, that once the fire is there, it is notified, and you are able to send a team to reduce it. But are there ways that you can actually predict in a way that what leads to fires and preventing that in itself?
Yeah, one of the things that we do we do have preventive reports that is location-based with which our devices are, and we send out reports weekly and indicate that this area has a high risk of fire. Please do some cleaning on the ground level, or you can use some preventive watering down and increasing the humidity sort of as solutions and suggestions. We do that as a weekly prevention method.
How do you identify that there can be more, this place is more likelihood for fires? Like, what kind of matrices do you use for that?
Sorry, can you?
What kind of matrices do you use? Like, how do you identify that this place could be more for a wildfire?
Yeah. Other than just giving there's a warning notifications, we do constantly get the live telemetry from the devices. So we do have the temperature, humidity, air pressure, air quality, CO2 levels. So we analyze them and we give a report regarding that. You had a question?
Yeah, hi. Do you see, you don't have line of sight to the satellite here?
No.
But do you see any problems with it? Do you need to place the sensors on a certain direction on the trees or so, or does it just work?
The only thing that we look for the direction is for the solar panels actually at the moment, because as long as the device is towards sun, it transmits data. As I mentioned, it is even transmitting here with upside down position as well. So we are not especially looking for something, but we are of course trying to minimize the transmitting power with directing the devices towards the satellite as well, as you said. But it is not necessary to have a line of sight. As far as I know, some tests indicated that it can even send a message through 1 meter of snow.
Hi. How do you solve the issues if your forest is very dense? So in that case, how do you connect to the satellite?
Well, it hasn't been any issues with the satellite connectivity if the forest is dense or not. We had some problems with the LoRa, and that matter because of the trees of the trunks tend to keep the water, and water is a dielectric. So, but because we put the devices on top of the trunks, like the 3 or 4 meters, we haven't encountered any problem, even if in the dense forests. So they're telling me my time is up. You can find me afterwards. Thank you for listening again.